In the last class, you have seen different types of activation function. So as the need of the hour, today I am going to pick up two major types of activation functions, which is a sigmoid function and tanh function, and we are going to see how to find out their derivative. Why? Because you all know that a activation function has to be properly derivable, especially when you have seen the case where we find out gradient descent. So when you are finding gradient of anything, if it is giving you a good value, then it is particularly, you can take that thing further in your neural network model. So today we are going to see two popular activation functions which I have already taught you, and how do we calculate the derivative of it. So moving forward, today we are going to pick the first one as gradient of a sigmoid activation function. So I already told you that sigmoid function is also called as a logistic function. So because it is used mostly in binary classification or logistic regression. So I have already explained you about the mathematical equation of a sigmoid function, that is 1 by 1 plus e power minus x. This you are supposed to remember. Now, why are we choosing this particular sigmoid function? Because of its excellent features, that is its ability to compress the value of the input between the range of 0 to 1. Now, the value of this internal is commonly used in machine learning or deep learning to express the following meanings. So, what are the meanings of squishing it to a value of 0 to 1? That is probabilistic distribution. So, the output of the interval 0 to 1 matches the distribution range of probability. Here you are not talking directly on the output, whether the output is 1 or 0. We are talking on whether what is the probability of output being 1, what is the probability of output being the other class, which is 0. So, we are talking on probabilities. So, the output can be translated into a probability by the sigmoid function, which is more realistic approach. Now, second is where else? Signal strength. So, suppose usually 0 to 1 can be understood as a range of a particular strength of a particular signal. Suppose there is a signal to be transmitted from one node to another node. Okay. So, what is the strength? Or else if you are working with images, then what is the color intensity of a particular pixel? So, if it is 1, then it means it is the strongest color intensity of that particular image. If it is 0, then it means the current channel or the current pixel is without any color. So, there are various ways in which you are benefited when you keep the output range in terms of 0 to 1. That is the reason we want to go for a sigmoid function. It can also be understood when you will later on work with RNNs, you will realize why do we require sigmoid function to understand whether a particular gate of a connection is open or closed. So, if it is 1, then it means open, if it is 0, if it is closed. Okay. So, all of these things gives you a very good approach with the sigmoid function. So, you can see here I have drawn a sigmoid function. So, I already told you the mathematical expression of a sigmoid function is sigma of x is equal to 1 by 1 plus e power minus x. So, you can see how gradually it is transitioning around, it is not very abrupt. Okay. So, now second important thing is, when you are really want to go for an activation function, you must have to see that it is properly derivable. Derivative of an active mathematical function is very, very important. So, what I am doing here is I am quickly finding out d by dx of sigma of x. So, it is one second. So, it is like d by dx of 1 by 1 plus e power minus x, which I am putting it as minus 1, apply simple derivative formula to it, and then you can see very simply I got e power minus x by 1 plus e power minus x square. Now, this is okay, you can stop it over here, but you always want to put it in standard notation. Okay. So, what am I supposed to do is, I am going to separate this denominator over here. So, I just separated the denominator, and I want to move ahead further, and I would write to like this, I would like to write this e power minus x as 1 plus and 1 minus. So, that does not make any difference. So, I am simply just trying to figure it out to put it properly, and now I got the proper representation. So, you can see this is sigma, this goes 1, and this is again sigma. So, the final d by dx of sigma of x is nothing but sigmoid function into 1 minus sigmoid function. I am trying to put everything in terms of sigmoid function, standard notation. So, this you have to remember, derivative of a sigmoid function is again in terms of sigmoid function. So, what you got is sigmoid function 1 minus sigmoid function. Why 1 minus? That also is very important because it is probability, right. So, if you are using two classes, if one of the class probability is 0.2, the other one is 0.8. So, what you are doing there 1 minus. So, you all know the range of probabilities from 0 to 1. So, to put it into that standard form, we have done this mathematical calculation, very simple. Now, talking about the second most popular activation function which we mostly use in hidden layers, tan h function. Now, why am I picking tan h function? Because the range of tan h function is from -1 to 1, which I already told you. So, tan hyperbolic function, you have the range from -1 to 1, and it is going to compress the input into an interval of that. And if you want to write the mathematical expression, this. Now, the second important thing is when you do a little bit of mathematics, you will come to know that you can represent a tan h function in terms of a sigmoid function. That I give you as a task. So, I already explained you, this is how you represent a sigmoid function, that is 1 by 1 plus e power minus x, this is sigma. You try to put it in terms of tan h, okay. So, tan h is also logistic like sigmoid, but that is, it is also probabilistic, but then the range is from -1 to 1, that is the difference, okay. And it is also S shaped, and it is also used for classification between two classes, okay. So, these are the similarities between tan h and sigmoid. Now, you can see here very clearly, when I drew sigmoid function, I could draw it in this way, okay. But when you see the tan h function, the cutting is at 0, and then it is going towards negative value, and the maximum range is 1, and between -1 and 1. So, that is how you are supposed to draw tan h function, do not draw it randomly. So, I already told you here, I am using tan hyperbolic of z as e power z minus e power minus z. You can use e power x also, does not make much difference. So, this is the formula, and I am going to derive it. Very simple, u by v division of differentiation is what I have used here. So, this is what I am getting, v u dash minus u v dash by v square. So, if you plot this properly, if you use the suitable formula of u by v differentiation, you will definitely get this particular answer, and you solve it properly so that you get it as 1 minus tan hyperbolic square. So, this is what is our thing, that we want to say that d by dz of tan hyperbolic function is going to give you 1 minus tan hyperbolic square. So, this is what we conclude with the derivative of a tan h function. So, you can see very simply the sigmoid function and tan h function, they both are very easily derivable, and hence they are very popular, but the only thing is you have to use them suitably based on what is the range of your output. If you want to keep it from -1 to 1, go for tan h, or else you can go for sigmoid. There are other functions like ReLU and ReLU also, for which you can find out the derivative, that I leave it on you. I have picked up two populars, and I have explained you on the same note you can calculate derivative of remaining activation functions too.